open Notepad, please. You go in Accessories, Program Accessories, and open the Notepad. And I do a similar thing. I open a text file. And this is my text editor, but it's, let me see if I can increase the font size. Yeah, it should be Ctrl plus. Okay, here it is. This is my text file. It's similar as Notepad, and I suggest you, before starting working, save the file in a given position. I suggest you the same position where you have the data. And I'm saving it, and I put the data in my desktop, so I save it in my desktop, and I call it first exercise. And you have to give an extension. You can give txt. I usually use S as an extension of R programs. This is just my habit. So you can give whatever extension. I suggest you to use txt or .s or .r. Probably .r is the best way, because so you can immediately recognize that it's an R file. And I'm using the S because R, 20 years ago, it was called S. And this is the reason why I kept this habit of naming my files in .s. But you can use, I suggest you to use .r. Don't worry. Okay. So let's suppose that we are at time 16, but we still don't have the data in R, because I forgot before moving forward to upload the data. So let me now go back a bit, and let me explain to you how to upload the data in R. Because we need a vector of rainfall, which is like 8,000 elements, hourly rainfall for 1 year. We need that in R. So let me go back to R, because this is just a single instruction, or let's say a couple of instructions that we have to make to upload the data. And remember that you have a text file with the data somewhere, which has to be uploaded. Okay, let me say that rain is equal to scan. This is the function that you have to use when you want to scan a txt file. Now you have to give the file name. So you open the double comma, and you see that I found it immediately because I'm working in the same directory where the file is. So I wrote RA and then the tab, and this is what it finds. Okay, there is one problem, which is that scan expects to find the numbers by default. And if in your file text there are characters, then it gives an error. And indeed we have characters, because you may remember that the first 3 lines, I think in the first 2 lines there were characters. And let me go back to the file. Let's have a look at the file, how it behaves. And this is the file that we are reading. You see, in the first 2 lines we have characters, and then we have an empty line. So we have to skip these first 3 lines, otherwise it gets an error. So I go back to R. I have to write skip equal 3. That's it. And then if I give enter, it says red 17,520 items. How many items would you expect hourly rainfall for 1 year? Let's make an attempt. Plus 24 times 365. it's 8,760, but then I remember that we have here also the evapotranspiration data. So let's see if what I get if I multiply times 2, I get indeed 17,520. The only problem that you may experience at this stage is if R doesn't find the find, okay? So you just have to give the correct path. Either you work in the same directory, or either you put the file in the R directory, or you have to give the correct path, which is C, document and settings, etc. If you put it in the desktop. And as far as I know, there is no way no other way of giving input data in R, if not by scanning the file. And one thing that I don't understand of Windows is the fact that the path of the desktop is so complicated by anyway. But anyway, you have to solve it. Can I check who was successful in getting the data at this stage? You, okay. Others? No. And the error is file not found, correct? The error is file not found.
Yes, but if I insert the path of the directory, C slash users, it tells me that after the backslash, you used without X digits in character string starting C.
Did you put the skip and try to make this attempt. Try to replace the slash with the double slash.
Double slash.
Double slash, yeah.
Slash of division or the backslash?
No, the slash.
Slash, okay. Now it works. With the slash of the division.
Okay, that's fine. Okay, that's fine. Okay, so everybody's reading. Okay, I just want everybody's reading. Okay, I just want to make a check, to draw your attention to the check that I made, which is very simple. I just made a check that the number of data that were loaded was the same number that I was expecting. And this is a very trivial check, but the message that I want to deliver to you is when you work with the PC, especially if you work quickly, every time that you have the opportunity to make a quick check, please make it. Okay, double checking when working in practice is always important. Now we have the problem that we uploaded rainfall data plus evapotranspiration data. Now we have the problem of eliminating the evapotranspiration data. And this is a bit tricky because what I uploaded is a vector. And let me show you what we uploaded just in order to get it clear what we uploaded. So let me show rain from 1 to 10 or to 20, let's say. This is the way to show the given elements of a vector. So what you see is 0 and 0.011, 0, 0.011. So let's try to understand what kind of data they are. And in order to understand, let me go back to the original TXT file, okay? It's here. So you see that the rainfall for a while is always 0. And the evapotranspiration for a while is always 0.011. Okay, so basically, given that our vector is given by 0 and then 0.011, 0.011, it means that R, when scanned this file, read by rows. Okay, so first row, and then at the end of the first row, it went on the second row. So is scanning by rows, okay? Good. Now, how can we manipulate this vector in order to remove the evapotranspiration data? To me, the easiest way is to transform the vector to a matrix, which in the first column contains the rainfall and in the second column the evapotranspiration, and then remove the second column. Let me do that. So let me transform rain, array, rain. This function gives to build, tells him to build a matrix that is called rain by using the vector rain. And in doing that, I am overwriting the vector. And I have to give the dimension of the matrix. Look, I hope you understand what we are doing, and please note that I have a doubt. I'm not sure if I have to give the dimension 2, 8760 or the opposite, 8762. And this matters because, you know, let me try. I just use a trial and error procedure. Let's try in this way. So now the question is it true that in the first column of this matrix I have only rainfall? Let me try. Rain, 1, 1, 10. This instruction visualizes the data from 1 to 10 in the first column. I'm checking if they are rain or if they are a mix of rain and evapotranspiration. They are all 0, rain, perfect. And now I have to remove the second column. So let me write rain, equal rain, 1, comma. In this way, I am overwriting the matrix rain with the first column of the matrix rain. Okay. Now, just to make a check, which is very quick, let's plot rain. Okay, that's fine. It's reasonable. It's probably better to plot with the line, so let me type equal line. Again, I go back to, or let me show both windows, instruction and plot. Here it is. Okay. Now we are ready to start with our computation, which I postponed in the txt file. But let me just define also the other vectors that we need, so we are really ready to start. I would say, let's put c equal 0.5. C is the runoff coefficient. And then let's also define the vector of the delta AK. And it's very easy. And let me call it AK. Or that's delta AK. Okay. And I use this function to define this vector. It's very easy. It's a vector with 15 elements. They are all identical. And their value of the elements is 1214 divided by 15. It's written there. It's very easy. But of course, there are several ways to define this vector. Please pay attention. Rep means repetition. How many times? 15. And what I should repeat? 1214 divided 15. And if you visualize the vector, no, I made some mistake. So let me see. I think it is. What I did is, sorry, I had to invert the two instructions. So let me go back. What I did is this one. Okay, I have to invert these two arguments of the functions. Okay, now it's fine. You see, the double check allowed me to correct the mistake. Okay, now we are really ready to make our computation. And as I said, let's make the computation in the text file, and you will understand later why. And so my file, which I already saved, I told you it's better if you save it, it's here. And now let me compute Q16, let's call it Q16. It's equal to, first of all, we have to include the runoff coefficient, C times and then sum, it's a summation of the vector, and then we have to multiply rain 115 times DAK should work. Let's save the file. And now we are ready to select this and copy and paste in R. So let me make Ctrl C, and then I go in R, Ctrl V, and of course Q16 should be 0, fine. Good. Now, we just computed Q16, which is not really what we want to do, because we need to remake the same computation until the end of the year. And of course, we cannot make it by hand because we cannot make the same instruction for 8,000 times. So at this stage, we need to introduce a for cycle. And given that I already have this instruction on the text file, it's easy for me to modify it in order to write down a for cycle. Before I go back to the text file, I want to make a check. Are you following me? Do you understand what I'm doing? Everything is clear? No questions? Okay. Question?
This one, my last one, did you use a file that we have just saved, or you rewrite?
No, I copied it here. You see? I used Ctrl-C, not really Ctrl-C because in Unix I have a different combination, but you should work with Ctrl-C and Ctrl-V, I think.
Okay.
Other questions? Okay, now let me stay here on the text file, and I inserted a blank line because here I need to get to put for E in 16 to, I think I can go until the end, yes. This is my for. But here, there is a problem that I don't have just an instruction after the for. I have a sequence of instructions. It's not just one. Or let's say that it could be also just one, but let me introduce to you how to structure the script, how to write the script when you have more than one instruction that is to be repeated within the for cycle. So what you need is to open I don't know how to say in English, it's not a bracket, it's okay, this kind of parenthesis. In Italian it's grapha. And now it's a challenge for you to find on your keyboard where the grapha is. And if you have a US keyboard, this is fine. Otherwise, try it with this combination of keys. So you should press Alt-GR, sorry, keep it pressed, and then try to press the key 7. Did you get it?
Alt-GR, Shift, and E.
A, okay. A is A.
A, yes.
A. I got a different one. It's okay, with the accent.
With the accent, yes.
With the accent, okay. Okay, that's fine. Anyway, you got it? Okay, good. Now, here, Q16, we cannot use Q16 as a variable because otherwise we overwrite it every time. So we need to write here QI. And now we have to modify also the indexes of rainfall. So basically, we start from 16, and okay, I think it's just enough here to write I minus 15, and here I, no, not I minus 1. Should work in this way. Yeah, should work in this way. And then we need to close the parentheses. save the file, and there is only one problem with this script. You need to define the vector before using it. R wants that vectors are defined before using them. The variable is not necessary. You can define a variable just using it. The vector is not possible. So let's define the vector here, and the best thing is to write q equal rep 0 x760. Now it should work. And now I can select it and go back to R, and then we try if it works or not. It seems yes, it seems that it worked. And now let me clean the screen, run it again, and let me try to see what is the shape of the resulting hydrograph. So plot Q type equal line. Let's see what we got. Yeah, not bad. At this stage, our exercise is finished. And of course, now you may have a lot of questions, like, is it reliable, this representation? This is a question that we will discuss next time. Because, of course, this is an important question. Like, you see that it was very easy to compute this hydrograph. And, of course, the question of the reliability is important, and I anticipate that the best way to check if a simulation is reliable is to compare it with the data, the corresponding data if you have them. Okay. I just want to bring your attention on the fact that now that the script is written in a text file, it's very easy to repeat it just by copying and pasting, and to change it, copying and pasting. This is why I suggested you to use this, to use a text file. And I just would like to tell you that it's very easy, for instance, to change the runoff coefficient if you want to try with 0.3. Then no problem, you repeat the script and then you repeat the plot. And of course you see that the flow is scaled, of course, you reduce the runoff coefficient. And it's very easy to use a time area curve that is not linear. Or if you want to increase the concentration time, very easy. Of course, if you want to increase the concentration time, then you have also to change a bit the code that we have written. To change the time area curve is very easy. You may try to use a time area curve that is non-linear. The only constraint is that for the time equal to the time of concentration, you have to get an amount of contributing area that is equal to the total area of the basin. But you can make whatever changes you want. And in particular, I mentioned to you the question on the reliability. When we will compare the data with the simulation, with the data with the simulation, then we may find that the hydrograph is not really well reproduced, and then we can make changes. It's easy. Now, given that we have 5 minutes or some more, the next step is to compare with the data. So let's now upload the data in R. The data, I mean the observed river flows, the observed counterpart of our simulation. Let's try to upload them and make a comparison. Okay? And where are the data? First of all, let me go back to my website, which is here. And here you see river flow data. So let's save this. Save link as I save it on my desktop. It's called portate.txt. Portate because river discharge in Italian river flows is called portata. So, and now let me go back to R, and I just need to know what is the number of lines to skip. I think 2. So let's see, river flow, or we could call it QOBS. QOBS equals scan, skip equal to. I think I just need to skip 2 lines. Let's check if it works. And yes, it works, because you see that there are 8,760 data.